Hello, welcome to software testing methodology. So today I am going to discuss about another applications in node reduction algorithm is push or pop and get or return. So what is meant by push and what is meant by pop? Generally it is a pair of operations of push or pop are generally used to insert the elements as a push into stack. Pop means removing an element from the stack. So the other complementary operations is nothing but push or pop and get or return or open or close, start or stop, whatever. So here we will see the arithmetic rules like parallel rule, series rule and loop rule. For path expression A plus B, AB, A star, and weight expressions as WA plus WB, weight of expression A plus weight of expression B. Series means weight of expression A into weight of expression B, and loop means weight of A star. And this is nothing but we can call it as a push or pop. If you take the parallel rule, if there are parallel path expression, every term in expression A is added every term in expression B. So result is then A plus B. So same as well as series rules also means in term in path A is multiplied with the term in the path B, nothing but the result will be A into B. Loop means if the loop represents the number of times the path is represented, the resultant would be A star. Star represents the number of iteration loop is repeated. So if you take this table for the push or pop, so P1, P2 and 1. So these are all some of the processes which defines. So P1 into, this is a multiplication table. Push is nothing but a push, P1 is nothing but a push, P2 is nothing but a pop, 1 is nothing but a no operation. So P1 into P1 is equals to 2 operations will be performed. P1 square in the above table. So P1 represents push operation and P2 represents pop operation, 1 represents no operation. When two push operations are performed, then the result will be P1 into P1, P1 square, P1 into P1, 1, no operation, P1 into P2, insertion, deletion, both should not perform at the same time. That's why it is a no operation. Again, P1 into P1, so no operation will be performed, but one element will be inserted as a push operation. So this is the defines, and here we take the P2. P2 into P1 is a no operation. P2 into P2, P2 square, P2 into 1, P2. So 1 into P1 is P1, 1 into P2 is nothing but P2, 1 into 1 is 1. So all can the same way with the two simultaneous pop operations, the stack pointer would be decreased by 2 as two elements are removed from the stack. So this is the multiplication table, very easy table which defines push operation and pop operation with no operation, the multiplication table. So the simultaneously push and pop or vice versa would result in no operation. So next we'll go for the addition table for push and pop. So this is the addition table. So P1 P1 plus P1, only one item will be deleted. P1 means push operation. P1 plus P1, only one item will be entered into the stack. So P1 plus P2, this is the P1 plus P2, and P1 plus P1 like P. So this is the addition table for push. The same analysis work for the addition which is shown in above table. So next coming to the text, we'll take the example flow graph and we'll define the push or pop. So same flow graph which consists of push operation as a P1 and pop operation as a P2 and no operation as a 1. So this is the path expression. We will obtain P2 into P2 plus 1, nothing but parallel links, into 1 into P2, P1 into P1. M1 means loop. This is a loop which defines like power P1 into P1 power M1. So this is the path expression. By simplifying this above expression, we'll get see this. So P1 into P2 in the table will define P1 into P2 is equals to 1, P1 into P2 is equals to 1. Here we'll apply that all P1 into P2. P1 into P1 means P2 square, or P2 into P2 means P2 square. P1 into P2 means P1. So by simplifying all this, this is the expression we will get. And so if you consider the values like M1, M2 is nothing but M1, M2 is nothing but inner loop and outer loop. If the inner loop is 0, repetition of 0, and M2 outer loop is also repetition of the first loop, then we'll substitute M1 is equals to 0 and M2 is equals to 0 in the previous expression, and the expression we'll get is nothing but P2 square plus P2. If this is the combination like M1 is equals to 0, M2 is equals to 1, if we substitute these values in this expression, so this is the expression we'll get, expression below. So And another case like m1 is equals to 0, m2 is equals to 2, and this is the expression we'll get. So these are all the looping probabilities or looping ways in the push and pop mechanism. So this is about push and pop. Next we'll go for this is the table. For example, for different combinations I already told m1 comma m2 nothing but 0 comma 1 1 comma 0 0 comma 2 or 0 comma 3 1 comma 2 1 comma 3. All this will get this. This is the push or pop graph analysis results. So this is about push and pop. Next we'll go for the get and return. The name itself tells getting the values and returning the values is a complementary action or operation which is same as push and pop. Same. There are some of the arithmetic rules to be followed, same similar to the push. So here in the push and pop we have taken like P1 and P2. Here we are taking like P1 means nothing but push, nothing but getting. Return P2 means return, like G and R. So G star G is nothing but G square. G star R is no operation. G star 1 is G. So same as RG means one operation. R star R is R square. R star 1 is R. So 1 into G, G, 1 into R, 1 into 1, no operation. So this is nothing but get or return problem. So in the above table, G is used for get, R is used for return, 1 is used for no operation. So same as addition table, same as push and pop, G plus G, G, G plus R, G plus R, G plus 1, G plus 1. Like this. This is the addition table for get or return also. So here also we are taking the example. So this is the example. So see this. This is the example flow graph which consists of entry node 1 and exit node is 7. So G means getting, R means return, and there is no operation which it didn't take the any operation with no operation. Like by considering this flow graph with all reducing the loops and parallel links and serial links, the path expression we will get is G into G plus R into G GR star GGR into R. So in the tables what we have taken in the multiplication table, G into R is equals to 1. So we substitute or where the GR is there 1. So G into 1 like, so all can be defined. This is the reducing expression, resultant expression which we perform the reducing of all using the multiplication table and addition table. So this is the resultant path expression achieved, G power 4 plus G square into R star. So this is about get and return. So hope you all understand about this push and pop and get and return application which is used in the node reduction algorithm. So thank you very much.